So the definition for the row space, let A be your m by n matrix having m rows and n columns, right? And A in the matrix form can be written as A11, that is the element present in the first row and first column. This m is representing the number of rows and n is representing the number of columns. So the entry A11 is the entry present in first row and first column. So this is A12, the entry present in first row and second column. Then is A13, so on. How many number of columns are there? N. So I should write the last entry as A1n, right? Then is A21, second row, first column. Then A22, second row, second column. Then A23, second row, third column, so on. So this is A2n. So likewise, if you go on, move further, so the last row will become, how many number of rows are there? M number of rows, right? So this should be AM1, mth row and first column. Then is AM2, mth row and second column, right? So on. So the last entry is AMN, mth row and nth column, right? The row first is representing as R1, then is R2, so on, and last one is Rm. If you notice over here, the first row, the elements present in the first row, how many elements are there in the first row? N number of elements, right? So the first row is containing number of elements as n. And the second row is also containing the number of elements as n, right? So all the rows are containing the number of elements as n. So if A be your m by n matrix over reals, then the vector space, this is very important, the vector space generated by these rows R1, R2 up to Rm, right? So the vector space generated by the rows R1, R2, R3, so on up to Rm of this A matrix, then this vector space is called the row space of A, right? And the row space of A is denoted as Ra, that is the row space of A, the matrix A, right? Thus, we can write this as row space of A. This is generated by the number of rows, that is R1, R2, so on, Rm, right? Okay. Please note over here, Ra is a subspace of Rn, that is the n-dimensional space over reals. Why? Because number of elements present in this R1 are n number of elements, right? So the number of elements present in each row is n. So this Ra, the row space of A, is a subspace of nth dimensional space over reals, right? Okay. And the basis of Ra does not contain basis more than, yes, m. Why? Because number of the rows generating the row space are m, right? So the basis of Ra does not contain the basis more than m, which means the dimension of this Ra should be less than equal to m. Either the dimension can be m or it can be strictly less than m, but not greater than m, right? This is a property for the generators of the vector space. So here R1, R2 up to Rm, the number of the rows of the matrix A, these are the generators of Ra, the row space, right? Okay. Next is the row rank of a matrix. The dimension of row space A is called the row rank of a matrix. Row rank of A, the matrix A, right? And the row rank of A is denoted by row R of A, right? This is your row rank of A, and this is equal to, yes, because it is the dimension of the row space A, so this is equal to dimension of the row space A, right? This is your row space and this is your row rank. Let's move on to a very important result. If A is m by n matrix over R, then row rank of A is less than equal to minimum of mn. So if this is your matrix A, that is m by n. The number of rows are m and the number of columns are n, right? Now since RA is generated by how many vectors? M vectors. Yes, since row space of A is generated by the number of rows, which means how many vectors? How many rows are there? M rows are there. So how many vectors? M. So the rows are denoted as the vectors. So RA is generated by M vectors, R1, R2, R3 up to Rm, right? Which are the rows of A. So therefore dimension of RA is less than equal to, yes, M, right? Because RA is generated by R1, R2 up to Rm. So the dimension is less than equal to M of row space of A, right? Please mark this as 1. Again, since row space of A is also the subset of Rn, that is the n-dimensional space over reals, right? Because every row of A is containing n number of real elements, right? There are total n columns, so every row is containing n number of real elements. So therefore, now the dimension of RA becomes less than equal to n. Please mark this as 2. Now in 1 we are saying the dimension of RA is less than equal to m. In 2 we are saying dimension of RA is less than equal to n. So from 1 and 2 we get that dimension of RA is less than equal to, we should write minimum of mn, right? So from 1 and 2 we get that dimension of RA is less than equal to minimum of mn. Dimension of RA is denoted by rho RA. Yes, so this is less than equal to minimum of mn. Right? Okay, thank you.